Alrighty, what is going on, everyone? So I did kind of what I said I would do whenever we left off last time. So I kind of did a little bit more work on this. Slowly kind of brought in components, moved them to a little more optimal locations. Try to kind of get them as close as possible because I think we'll end up being able to shrink our board down a little bit. So this is kind of where it is when I'm going to begin the routing portion of this. The routing phase of this project, right? So I'm going to leave the board the way it is for now, and then after we're done with it, then we'll shrink it in even more because I think we'll be able to save a few inches, or a few inches, I don't know, a few centimeters off of this bottom edge, and then a decent amount off of this edge right here. So yeah, so I think we're fine with going into the routing portion now. So we'll just take some look at the notes I have for the routing. So we're going to start, of course, with the AC input. So little notes I have on routing is make the traces very wide to accommodate high currents and high amounts of power. This is both for, so you might think, well, our circuit isn't actually providing that high of a current. Like I think our input current is like maybe less than an amp or right around an amp or something, which, I mean, that's actually kind of high for a board of our size. But what I really want to stress here is that in the case of a malfunction, right, we could be dealing with higher currents, and so we don't want to have like a catastrophic malfunction on top of a catastrophic malfunction and things start to like burn up and catch on fire because our traces can't accommodate high currents, right? Especially when we can afford it, right? It's not like we're hurting for space around this input section, so we have more than enough room to accommodate, you know, traces of 100+ mils. And that would just provide like another layer of safety for us in case of a board malfunction. So yeah, we can jump into the AC routing portion of this now. Let me see. So no ground planes used here because the routing is very linear, plus we can get further isolation with individual traces. So this is again another safety feature. We're not going to use, so you don't use a ground plane in the first portion of your layout, and then we'll use ground planes whenever we get to like the section around the controller. Use through hole components as natural vias if you need to cross layers, and this is a good note because we have a couple surface mount components here that we have to actually quote unquote cross over. So yeah, so I'll just go ahead and I'll start doing the trace routing, and then I'll, you know, take moments to pause and make any comments that I deem necessary. So that's pretty much how we will do it. Alrighty, so you kind of see where I came in here. Maybe we'll take a look at the 3D view just to see what we're looking at. Okay, let me see. Okay, so where we first started, and you can barely see the layers, but here we can look from the bottom. And so our first trace we just routed, literally just, it looks very linear, right? Just going through the various components. Like I said, we're not using the ground plane because there's literally like, there's only like 2 or 3 components in this section, right? It's not like we're trying to ground like 20 or 30 components over here. So we'll get to that stuff, the more high density routing later. Another comment I guess I should make is, so with regards to component placement, you see how we need to account for these long pins, because these are what will be placed in like real life, and these will end up getting clipped. They'll be chopped off during manufacturing, but that's how they're placed onto the board for like soldering and stuff, and then after they'll get snipped for us. So like I said, we wanted to make the traces as thick as possible, and again, I said we had no problem doing that, so that's kind of what we did. There wasn't really any rhyme or reason why I chose to go on the route on the top layer versus the bottom layer. It doesn't really matter. I don't think it'll change much for manufacturing costs. But all in all, yeah. So like this part is pretty simple. It's pretty straightforward. Like I said, routing interfaces between like high AC voltage and a rectifier circuit is something we'll probably get a lot of practice with, because pretty much every power supply that we start with will probably have something to do with that. So yeah, I think this will honestly will wrap up this portion of the AC routing. Like I said, it's very straightforward, very simple. Like I said, we used the through holes as some natural vias so that we can go between. We went from the top layer to the bottom layer. So I mean, we technically didn't even need to do that, but yeah. So you'll see later on. Let me double check and make sure. I actually think we might have missed this. Yeah, so we want to make sure. There we go. See, also it's good to go back and double check things. See, as I'm reviewing it, I caught a mistake, which is totally fine. Like, these things take multiple iterations to go through, and it's good. It's a good habit to get into, to just keep checking over things repeatedly, because like I said, you'll catch some of your smaller mistakes, and that's totally fine. So thank you so much for watching this video. Please drop a like if it helps you out at all. That'll really help my channel out a ton, so I really appreciate it. And subscribe if you want to stay up to date with all of the content I'm posting in this power supply project. I'll post content regularly, and I also post a lot of electrical engineering related content. So thank you so much for watching this entire video, and hopefully I will see you in the next one.